The Pythagorean theorem is a theorem used to find the missing sides of a right triangle. The equation of the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. The Pythagorean theorem can also be applied to trigonomic ratios as well, so we'll be using this triangle to demonstrate how. So let's first find the sine and cosine of angle z. If you refer to SOHCAHTOA, sine is the ratio of the opposite over the hypotenuse. The opposite of z is 4, and the hypotenuse is 5. So the sine of z is 4 over 5. Cosine is the ratio of the adjacent side divided by the hypotenuse. The adjacent side of z is 3 and the hypotenuse is 5. So the cosine of angle z is 3 over 5. Now let's try to apply these to the Pythagorean theorem. So now we put these two ratios into Pythagorean theorem form. So we substituted a with sine z and b with cos z. And the x represents c squared. However, the x in the equation does not represent the x on the triangle. Since we know what the sine and cosine of z are, input them into the equation. So we have 4 squared over 5 squared plus 3 squared over 5 squared. So if you solve the current equation, you'll have 4 squared plus 3 squared over 5 squared. So now you solve 4 squared plus 3 squared over 5 squared. 4 squared plus 3 squared is also 16 plus 9, which is 25. 25 is 5 squared. So you could replace the 4 squared plus 3 squared with the 5 squared. A number divided by itself is 1. So 5 squared over 5 squared is equal to 1. This means that the sine of z squared plus the cos of z squared equals to 1. And this is how the Pythagorean theorem also applies to trigonomic ratios.